Hello everyone, I am Anurag and welcome back. This is the sixth experiment of System Software and Compiler Lab, in which we have to work on the signal pass assembler for SIC. So aim of the experiment is to simulate the concept of single pass assembler for simplified instructional computer, which is SIC. Let's go on to the description part. An assembler is a program that accepts as input an assembly language program as source, which is also called as source, and produces machine language equivalent, which is the object code along with the information for the loader. The advantages of this code is the assembly languages provide more control over handling particular hardware components, and it also generates smaller, more compact executable modules, and lastly it also executes faster because results are faster, produce faster execution in results. So let's go on to the algorithm part. So what we are doing is initially we are reading and opening and reading the input file. Then after that, if the input line has the opcode start to do the following. If we are going to find any operand field after start, then initialize LC to the operand value. Then otherwise, if it does not work, then if there is no value in the operand field, then LC is set to 0. And we then the third step, write the input line to the immediate file. Then do the following steps and then opcode is end. Then in the section of the 4.1, we are checking the symbol table. If the symbol table is not available, then enter the symbol to the SIM tab along with the memory address in which it is stored. Otherwise, the error message will be displayed. For the second step, part 4, we are doing, if there is an opcode, then what we are going to do is at the first part of 4.2, we are doing if opcode is present in the opcode, then increment the LC value by 3 and start writing the location counter, opcode and operand fields of the corresponding strings to the output file along with the object code. So next step is if opcode is word, then increment by LC by 1. If opcode is byte, then increment LC by 1. Sorry, previously if the opcode is word, then increment LC by 3. If it is byte, then increase LC by 1. If it is reserve word, then we are going to increase LC by the integer equivalent of the operand value into 3. Then therefore if the operand is the reserve byte, then we are going to increment the LC by the integer equivalent of the operand value. Then if there is no symbol label in the operand, then operand address is assigned as 0 and it is assembled with the object code of the instruction. Then after that, the process line in the intermediate file along with the location counter. So to find the length of the program, we subtract the starting address of the program from the LC, and lastly we close all the files. So let's go on to the program part. So initially we have declared all the required header files and the variables required for this program. Then after that we are asking the user to then we are reading input.txt file, and then after that then what we are doing is first reading, then we are comparing if any other section has null value or not, until null value or not. If the values goes until null, then what we are doing is we are just in the array line 1, we are increasing the space by we are increasing the tab, including the tab space, then incrementing the value of I. Then after that, if the W array is equal to nothing, then we are incrementing the value of J. Else, if that does not work, then what we are going to do is we are assigning the tab if line array is equal to tab space, then what we are going to do is we are incrementing the W array, and we are going to add line value to it. Then if that does not work, then what we are going to do is we are going to run one more if statement, where if W of J is not equal to nothing, then that means we are going to increase the value of J. Then after that we are storing the line I the value of line I to the array of wj, then we are incrementing the value of I. Then what we are doing is we are displaying the output optab file. Then from the optab file, this part of the program focuses on displaying the data from the optab file. Then after that, we are going to open output.txt and we are going to write the input into it. We are going to write the output into it. Then if any error comes, then we see when will the error come. If the symbol already exists in the SymTab, and towards the last we are reading the SymTab.txt file and displaying that file to the user after running the program. So this operation, as we can see, finally we are writing every bits and pieces, that every section of the program to external file, which is output.txt, and lastly we are going to display that output.txt, and we are going to display that thing as an output. And later on, this cases A, B, C, D, E, F is used for hexadecimal conversion. So earlier in the algorithm part, I've talked about the conversion, right? We are going to use this hexadecimal conversion as in here. So this hexadecimal conversion we are going to perform here. And here what we are going to do, we are just incrementing the value of the hexadecimal. So this is the last. Now let's go on to the working part. So first we are going to see through the input file. Okay, input file. So we have placed this program into the input file. Then we are going to look through another file, that is operator table. As we can see here the operation table is given. Then we are going to see the last table, which is the symbol table. Then we can see here the symbol table, as we can see here. Then after that, we are going to compile the original program, that means vi, that means compiler6.cpp ++6. See, after the compilation, we are going to run this program. As we can see, the first initially all input file has been displayed. Then after that, operator table has been displayed. Then after that, symbol table has been displayed, and this is the last of it. Thank you. Okay. So there was a earlier I did notice there was a segmentation fault. So in order to remove the segmentation fault, we have to edit the symboltab.txt file. So we are going to do it now. Edit. So first we are going to remove all the other values except the beta and alpha values. And we are going to save the file. Then after that, we are going to run the program. Now we can see the symbol. There is no segmentation fault, and the symbol table file has been created. Now we go to the output file, vi output.txt. Now we see the program has been created. See, the output has been created, as we can see here. So wait, where is it? See, the output, finally the output has been created, as we can see here. So this will be the last of it. Thank you.